Good afternoon, everyone, and welcome to our webinar, Moving Data at the Speed of Business. I'm your host, Helen King. Is your business on its back foot when it comes to collecting and processing data, indicating the status of your operations? Most organizations are. It's time for supply chain leaders to take a huge step forward and learn to incorporate data from sources like GPS, telematics, sensors, mobile devices, Twitter, and machine-to-machine transactions to accelerate supply chain decision-making. This webinar is designed to highlight the opportunities and strategies to incorporate streaming data into everyday data collection practices. Before I hand this over to Laura and our guests, there are a few things I want to cover with you. We're recording today's session and we'll post it to our on-demand webinar page. You can visit our website to listen to this and any of our previously recorded webinars. Additionally, we'll send out the slides to all attendees within 24 hours. We encourage you to share these slides with others in your organization. And if you have questions, reach out to Laura or myself to set up a private discussion. We want to hear your questions about what is presented here today. So please post to the chat or Q&A function to the left of your screen. We've left time at the end of the webinar to address your questions. Finally, we will be live tweeting the webinar. So if you would like to join the social media conversation, you can use the hashtag SCIWebinar and the handle SCInsightsLLC during the event. Finally, our host Laura Ceciri, founder of Supply Chain Insights. Laura spent 9 years as an industry analyst at Gartner Group, AMR Research, and Altimeter Group, 10 years as a leader in the building of supply chain software at Manugistics and Descartes System Group, at 15 years as a supply chain practitioner at Procter & Gamble, Kraft General Foods, Clorox, and Dreyer's Grand Ice Cream, now a division of Nestle. As an enterprise strategist, Laura focuses on the changing face of enterprise technologies. Her research is designed for the early adopter seeking first mover advantage. She comes to the stage with over 40 years of diverse supply chain experience. Welcome, Laura.
Okay, thank you very much. I apologize for the audio issues. This is Laura Ceciri. I'm the founder of Supply Chain Insights, and each month we have a topic on next generation supply chain. And it's part of our ongoing webinar series to really connect supply chain leaders with supply chain technology visionaries. And we pick a topic that really focuses on next generation supply chain thinking. And in my research, I study the evolution of platforms and technologies. And one of the things that I've been very interested in is streaming data or real-time data. Most vendors will talk about real-time data or real-time visibility. But supply chain processes are largely batch, meaning that we gather data together and then we run algorithms or then we run a UI which gathers the data together. And most of the data does not come in the supply chain when we need it. It'll be out of time sequence or perhaps it'll be transposed data. And so we have an issue with what I'm going to call real-time data. And in my research on real-time data architectures, I've found 3, and one that I'm impressed with is the Savvy technology architecture, which is built on Apache Spark. And Apache Spark is an open source form of code that I've invited Jim to come and talk about today and to talk about the work at Savvy. Now, Jim is the Executive Vice President of Products at Savvy and has been leading the product efforts. Jim, thanks for joining our webinar.
Thanks for having me, Laura, and it's a pleasure to be here. Thanks for everybody else for joining. So I'll just give you the... Go ahead.
Tell the group a little bit about Savvy and what you do, and then we'll get started.
Sure. So at Savvy, we capture live streaming data, and our goal is to deliver visibility and insight into the billions of dollars worth of goods that are in transit across the globe at any minute. And we do that using big data architectures, and we try to add contextual information, so it's not just a fact about what's happening in a remote location, but it's also what does that mean to your business. And if we're doing that well, we're doing our job.
So, Jim, you know, Savvy's origins were in sensors and work with the Department of Defense. Can you give the group a little bit of an understanding about that history?
Sure. So this history started after the first Gulf War, when after the war there were millions of containers left in the desert and nobody knew what was in them, or people looking for certain things couldn't find them. And so the DoD said, well, we're not going to do that again. Let's find a way to tag and track all of the goods that we ship overseas and with our NATO allies. And so we developed the initial technology using RFID technology to be able to track these shipments going from the primarily continental United States outbound to wherever the U.S. Department of Defense needed them.
And Jim, how did you end up with Apache Spark? How did you end up in the open source world versus the more closed and proprietary architectures?
Yeah, it's interesting. So we were doing this on one of the classic relational database vendor technologies, and we were started to run into scale issues. We're dealing with millions of events coming in every minute, and those architectures just weren't built for that. As you say, Laura, they're built for big data, but they're built for processing that data in a batch mode and delivering you data the next day based on what they're able to process the night before. And that's not what was needed to be able to solve this problem.
Okay, so what we're going to do today in our webinar is we're going to ask the audience to think about redefining time in the supply chain. And as we think about time and we think about the ability to get data, one of the things I want people to think about is that today's processes are batch historically. They don't move at the speed of business. And I'm not saying that all data needs to fly first class, real time. There is a role for slower moving data or nightly processes, but we don't have data architectures that move at the speed of business. And think about the speed of business. Speed of business is when do you need data to make decisions. Today's supply chains largely respond. There's no sensing to drive the response, and what we're driving is sense and then respond through the use of artificial intelligence and pattern recognition and the advanced use of sensors, which means that we've got to move streaming data from the sensors into some intelligence layer to drive a response. The traditional supply chain architectures have been built largely on optimization with a predefined data model which takes inputs and drives outputs. The traditional architecture is pull. We pull in the data when we need to make a decision, and then we drive an output. But here we're talking about pushing data from sensors, whether it's programmable logic controllers on a machine floor, or sensors on a pump, or sensors on Caterpillar equipment and mining, or telematics data for trucking. This data is pushed to the outside world for usage, and then it has to be really transformed into a new process. And this requires the work on outside-in processes where we move outside in. So we're using sensor data versus our traditional thinking, if you think about the SCORE model and the APIX work and the CSCMP work, has all been about inside out. It's about waiting for data, putting it in a batch process, driving decision support, and driving an output. So as Jim and I talk today, I'm going to ask you to challenge yourself on these four paradigms that really are going across all of the process definition that we've had historically. So Jim, when you think about moving data at the speed of business, what does that mean to you?
Well, as you said, Laura, companies are making decisions all the time, and the speed of business is constantly increasing. So today, these decisions are being made in real time, but they're based on the most recent data that was available to make that decision, and in too many cases, that's stale data. So to me, the companies that can capture that operational data that is available in real time and combine it with that other relevant data that you mentioned is okay to be processed in batches, they're going to make the better decisions and be more competitive.
So in this work about building streaming data architectures, what have you learned? What's important? What defines a good streaming data architecture?
Sure, we've learned a lot, and I can tell you, capturing and processing the streaming data, it's an order of magnitude harder than dealing with batch data. It comes out of order, it comes duplicated, delayed, dirty, and you need to be able to deal with that. So To be able to make decisions off data you trust, we've had to do things like build self-correcting algorithms to resequence data in the way it should have been transmitted and captured. Then those decisions can be made with a certain level of confidence, right? And that's our goal, be able to put insight in front of business decision makers that they can be confident in.
So, the data architectures are large, and the data comes out of sequence, and it's moving at a speed in which most architectures don't understand what to do with it. And, as we look at, Supply Chain 2030 and 2025 and the future, and we ask people what's important, today they're looking at advanced analytics, which for many people is just reporting. About 7% of companies are working on cognitive learning, and we're starting to see some work on rules-based ontologies. But this Internet of Things world, where we have machine-to-machine discussions, where we have autonomous vehicles and robotics, and we have the use of telematic signals, is going to require streaming data architectures. And I think it's about confluence of architectures for us to really move forward. And I also think it's about the analytics and thinking about clouds and the fact that many of the sensor output goes into clouds and building streams of data, but also allowing data to pool in certain areas of the company so that it can be harvested by different forms of analytics. Most of our architectures are really batch. We're new into the cloud, and we haven't really defined streams of data or this real-time data very well, and we haven't really thought about, how do we mine the data in data lakes to answer the questions that we don't know to ask. Now, one of the issues that we have in supply chain is that we've become more conservative, and many companies, when they hear things like Apache Spark, and Jim's going to talk about that as an open source technology today, they're like, what? Scratch my head. I don't know what that means. I'm used to putting internet data or sensor data into relational databases and moving it into traditional architectures. And I found that that just isn't working in my I'm finding that people need to embrace open source and new forms of technology like Apache Spark. So one of the barriers that we have as we talk through the examples is that the buying audience has become more conservative, and this type of discussion is really more for the innovator and the early adopter. So, the barriers to driving the continuous improvement in this area is really traditional supply chain thinking and a lack of organizational alignment about what does an outside-in process look like and how do I define streaming data to really be able to drive improvement. And one of the things I'm going to do to set the stage before I turn it over to Jim is I'm going to give you some examples. So one of the companies we work with that spoke at our last conference is Lennox International. And Lennox makes air conditioners. And one of the issues that they have is the fact that air conditioners usually break on the first day of the summer and the first day of the winter because people will crank them up and they'll always need parts at that point in time. Now, the traditional way that we've gone about solving this problem in the supply chain was spare parts optimization. We worked a long time on lumpy demand and looking at where should we stock parts. And Lennox, as an organization, had 1.5 million SKU locations, and 95% of these parts were slow or intermittent demand. And they looked at climates because the air conditioners were serviced based upon climate change, but they found that the climates were really far more granular, like the right-hand side of this particular PowerPoint. And so what they did was they had to really rethink that they needed to say, could they redefine streaming data architectures to sense off those air conditioners and to redefine service? So instead of predicting when something would fail, what they would do is they would take the output of the unit based upon the more granular information upon climate and redefine service. And this is what they are working on. So instead of calling someone and saying my air conditioner has failed, they're taking the input from the heating, ventilating conditioner and the thermostat, and they've built artificial intelligent analytics to really drive a signal to the dealer, have the dealer call the residential homeowner or the commercial homeowner and say, there's a problem. We think that you're going to have a failure within 30 days, and could we schedule an appointment? Oh my gosh, I love the redefinition of service because, I sit at home all the time waiting for service people to come in a 4-hour window, and they never come. And, high issues with service, and we've never been able to really drive decisions on service parts that have been effective. So I think one of the use cases is redefining service. Another case study that we had at our last conference was Costa Express. And if you think about vending machines, and McDonald's could have done this with Coke when they put in the new Coke dispensers, but they didn't, is Costa Express, which is a coffee company in England, said, let's outfit all of our outlets in England so that the machines will send a signal, and the signal of the machine will drive replenishment. Now, you think about replenishment today, we take forecasts and we do forecast consumption, and then we have DRP logic, and they said, do we need that? Why not, excuse me, take the signal directly from the coffee machine and send it and let that be the replenishment signal. So they worked to build these machines, and in the process, they redefined replenishment and back office operations to really say, what do we need in each of our outlets on a real-time basis? And how do we drive that? So if you think about all of the processes that we have in supply chain, whether it's tank sensing on VMI or rail car movement or maybe automatic usage at a customer, today we don't have any place to use that. But could that redefine replenishment? And so they've thought about reinventing the back office systems. Now, Lennox and Costa are two good examples, but another good example we had was listening and sentiment mining by Lenovo, where they have listening posts to really listen to social sentiment of what's happening with consumers around the world on social architectures, unstructured text. So in these architectures, we have to think about unstructured text. So in this case, Lenovo has parts of the world that they're listening for, and they're listening for what's going on with my new product launch and what am I seeing from customers. So the definition that I've talked about, Jim, for some case studies, I know you've got some case studies you want to go through. Would you call my case study streaming data architecture, and is there anything that you would tell the audience about those case studies that you think would be relevant?
I agree that those are two very good use cases of streaming data architectures. It's let me know what's happening in a remote location right now with the best information you have, so I can make the best decision. And being proactive in your decision making is a lot better than being reactive. And as you said, most supply chains are reactive today. So I think those are two great examples.
Okay, so Jim, why don't we go through some of your examples now, and we'll talk about the definition of the architectures as you go along.
Sure. So we capture data that tells us what's going on with a container of goods, a shipment, in a remote location. And we capture that using various sensor data that's available or any data that's available. So we capture telematics data from the carrier's truck, their GPS device. We have mobile apps that drivers can push a start button, and we can then tell where that shipment is and predict how long it's going to take to get to its destination. One of the other streaming data sources we capture, it's a really high volume data source. It's the AIS vessel location data. Every ocean-going vessel is required to transmit their location every 5 minutes. And that may not sound like it's streaming, but when there's 15 million vessels out there and they're all signaling their location, and if they get closer to the shore, they're doing it every 30 seconds or so. The goal of that system is collision avoidance. We repurpose that data to be able to find the exact location of a shipment on that container vessel. So those are just some of the various data sources that are coming at us streaming that we need to be able to catch and process.
So Jim, now let's talk about Apache Spark. You know, when I talk to clients about Apache Spark, most people haven't heard of it. So let's just kind of debunk it and get into the details for people.
Sure. So on the next slide, we see that this is not a technology that's been around for a long time. It was invented in 2009, first distributed as open source in 2010, and then really started getting the attention of Apache around 2014, where they made it a top-level project. And it was getting attention because there was a need in the marketplace for this capability. The ability to capture streaming data, to process this data as it's streaming through. Apache Spark offers a few other capabilities. SparkSQL for querying the data. It's got a machine learning library for building predictive models. But the primary use that we're focused on, we call complex event processing, and that is every time I'm getting a streaming event, capture it, understand it, and figure out what to do with it. It's built for
Jim,
infinite, yeah.
So Jim, this is not something that you sell. I mean, most people don't know what Apache is. Give a little bit of understanding about who's Apache and how did this happen?
Yeah, so they're in it for the greater good of the technology company. Well, they're probably in it to make a little money while they're at it, but it's this concept of open source. And open source means here's this software, and anybody on the planet that's qualified can contribute to making this better. And so the first example of open source was probably the operating system Linux that was contributed to by thousands of open source programmers, and that is in mainstream throughout every business, or something like Linux is deployed everywhere on the planet now. So imagine having your own set of 1,000 programmers doing nothing but making one aspect of one product good. That's essentially what open source data does for you. It gives you a programming team that allows you to use this at very low cost compared to comparable technologies out there.
And Jim, you know, people can build it themselves, right? You know, I often will find people that will build it themselves. It's not something that, you know, you just have to buy from a vendor, right?
That's right. You can go right to Apache and say, hey, I want to take your open source data. I want to try it. And typically, once it starts getting some momentum behind it, then what you find is more and more releases and more frequent releases and more capability added to it. And so it's focused on being the fastest, most efficient data processing engine there is in the world. And they do something called a cloud sort benchmark, and that benchmarks how fast you can sort a terabyte full of data. And a terabyte full of data, for those of you that don't know, is about 2.8 billion EDI messages. And the cost to do that, to sort a terabyte of that data, is $1.44. That's incredible. The closest anyone had come to that before was about $7 per terabyte, and that was on a machine that had the processing power that NASA uses. So this is a remarkable technology. And if you look at some of the bottom line impact here, it's 900 times faster than what you're currently seeing in enterprises. It's linearly scalable through distributed processing. That means there's no limit to how much data it can process. And it's certainly easy to cost justify. The thing that the most challenging thing with deploying this technology is finding software developers that are familiar with it. It's only been in production at industrial scale for 2 or 3 years now. But it works, and it's proven, and more Fortune 500 companies are figuring out that open source is the way to go, and then they're not handcuffed by these large vendors of proprietary technology.
So Jim, we've got a question from Marvin. He says, is Spark a database? Is it a chip? Is it a language? You know, can you talk about it in a more granular detail?
Sure. It's more like a programming language that's used to access data in databases, and the database, it's typically going after is one called Hadoop, which, by the way, is also an Apache open source database. So it's more of a programming language that allows you to do certain things, go after batch data, as well as provide complex event processing, meaning if I catch an event, hang on to that, put it in memory, and see what other events coming around it so I can make decisions based not on a single event, but in context with the other events I'm seeing. And so it's time-ordered processing, it's rule-based, and the most important enhancement was its scalability.
So one of the discussions I was having with SAP the other day is the streaming data capabilities of HANA and the capability comparison to Apache Spark. I've not gotten an answer to that question, but I think that would be a good question for people that are looking for streaming data architectures to ask and use this data as a benchmark. Do you have any perspective there, Jim, on the work with HANA or JSON connectors and the comparison to Apache Spark?
Well, I think when you have open source, when you have contributors from around the globe with different backgrounds contributing to an open source, you get a much broader functioning capability than you do with one company working to solve a problem. And I think that's just in general what you get with open source technology, never mind the price tag associated with the other technologies.
So Marvin comes back and says, so Jim, roughly it's like SQL but for streaming data on Hadoop. Would you say that's fair?
Yeah, that's fair. That's fair. As a matter of fact, one aspect of Spark is SparkSQL, and it's a SQL-like language. It's not exactly ANSI SQL that most SQL programmers are used to programming in, but it's not much different. There may be a 10% variance. So if you know how to program in SQL, you can quickly pick up SparkSQL.
Okay, good. Marvin, we appreciate your questions, and we look forward to questions from the rest of the group. One of the things that we're trying to do at Supply Chain Insights is really shine a light on alternative ways that we can build next-generation supply chain capabilities. And, you know, streaming data and Internet of Things is, I think, a really important thing for us to think about how we build these architectures. So, Jim, let's continue. I've got the slide up about how do we use Apache and Spark in the ecosystem. Sure.
So if you look at just kind of a generalized system, most systems that try to capture streaming data, there are producers of this data. In our case, it's primarily sensors of some sort. You need to ingest this data, get it into the area where Spark is looking at it, and then you can apply logic in a speed layer. That CEP there stands for complex event processing, and that can be general data cleansing as an example. Let me look at the timestamps of this event compared to the one I got before this and after it, and if they're out of sequence, let's resequence these before I actually put it into the domain-specific complex event processing, which tends to have the logic that tells you what to do based on capturing this streaming data. On the bottom half here, you see a batch layer, and this is an important concept with these database systems going forward. You want a speed layer and a batch layer that are in sync. They're dealing with the same version of the data. In that batch layer, you do some of the heavy lifting. In our case, we're building these machine learning models that predict the estimated time of arrival of a shipment based on where it is from the sensor, the state it's in, and a lot of other variables like weather, time of day, those types of things. And so we capture this streaming data, and we then apply a machine learning model to it in real time. And it generates, from the domain perspective, the estimated time of arrival that's sent downstream to somebody that's going to consume that and do something about it if that shipment looks like it's late or it's compromised in some fashion. If you look at the bottom of this slide here, these are all open source technologies that we've stacked on top of one another. They're all by Apache or related to Apache, and they're meant to work together. And this is the future, I'm convinced. This is the future of where enterprises' data centers are going.
So, Jim, let's just spend a minute. So Spark is helping us with streaming data, and the little elephant here is Hadoop. And talk a little bit about what is Hadoop, because most people are used to working in the SAP, Oracle worlds of relational databases. Talk a minute about what is Hadoop, because we find only 2% of supply chain leaders know what Hadoop is, and they're not familiar with the elephants, and they'll say big data and not really know what that means.
Yeah, so Hadoop, or the Hadoop distributed file system is a way to capture data and store it and then process it focused on high-speed retrieval of the data. And it's not necessary to have a schema associated with it. So that's what's different than, say, a typical relational database. You have a schema that says, this is the table, these are the fields, these are the data types of these fields, whereas Hadoop is meant to be able to capture any data, whether it's structured, whether it's unstructured, and allow you to process that in a distributed fashion. That's what that distributed file system means. I can divide and conquer this at a granular level that other databases can't. And then you see some things here like Solar or Parquet or Cassandra. Those are layers that go on top of Hadoop to give you a level of abstraction to be able to look at it like it is a relational database.
So if somebody was interested in building streaming data architectures, they would look for people that are really conversant and knowledgeable about big data, right?
Sure, it's big data and it's this distributed processing technology, and it's the intersection of those. And that's where some of the bigger advances have been made, in taking your workload and distributing across multiple nodes or CPUs to be able to conquer the problem in a more timely manner.
Okay. Now, you've been working with the Department of Defense, but I know also you've been doing some work on the commercial side, and one of the things we've been working on, or you've been looking at, is how do you sense on container movement. Let's talk about the so what, who cares. Let's bring it back to the business level. Talk through this case study.
Okay, so here is a shipment of finished goods going to a retail outlet, and before you ship, you work on a contracted plan with a carrier. The plan for this shipment was to go from a truck in my warehouse to the port of Jacksonville, and then on an ocean vessel from the port of Jacksonville to Port of Limon in Costa Rica, and then a truck from that port to the retail store. And as far as this manufacturer or shipper knew, this was the route it was taking. Well, what actually happens, and this happens quite often, it got to the Jacksonville port, but then something changed. It got put on the rail yard and went from Jacksonville by rail down to Port Everglades. And then it got on a different vessel, and it didn't go directly to Costa Rica. It first stopped in Jamaica for 2 days. So there's now latency built into the shipment that I hadn't anticipated. And then when it eventually got to Costa Rica, it got on the truck from Limon to the retail store. And so if I were trying to manage my business looking at EDI message data that was associated with this, here's what I would have seen. After it had already departed the Port of Everglades on a different vessel, I got a message that says, hey, it's arrived in Jacksonville. Then I got a message saying, hey, the original ship departed Jacksonville. And then I got an out-of-sequence EDI message saying, hey, it's been loaded onto that vessel. When, other than it eventually got to Jacksonville, none of that actually happened. And then after it already arrived at the destination, I get messages that tell me the container's been loaded onto this new vessel. The vessel's departed the port it was supposed to leave from. And then days later, it arrived. And so what we see here is data coming in late and completely wrong in some instances.
So why do I care?
Yeah, so why do you care? In this specific instance, there was an additional 2 days introduced into the shipment. At the very end of the retail store, that can mean empty shelf space, and that can mean, depending on who that retail outlet is, you just lost shelf space that you'll never get back again. So knowing something's going to be delayed, maybe you could have gotten an alternative shipment there, maybe you could have flown something there, just enough to keep those shelves filled until that shipment got there. The point of this is, had I had a sensor associated with this shipment, I would have gotten every single movement and then known every single departure and arrival.
And so it's really almost prescriptive visibility.
Right. So with the EDI messages, we saw significant latency on the order of days. Arrival of these messages out of order. They were just wrong in certain cases. And you get the carrier version of the truth. You get what's reported to you by the carrier because it's in a remote location and you can't validate it. What you can get with the streaming data is what's happening right now, what did happen from all the way from the origin to the destination. You can get notifications every time it reaches one of these points of interest, such as a port. You can get an alert if it deviates from your shipment plan. This is what I'm paying for. I paid for this shipment plan. If it's not going to be shipped along that plan, I want to know that. And you can also, over time now, look at this data and then understand a lot more about your carriers, your shipping lanes, and you're getting the observed version of the truth, the sensed version of the truth.
And Jim, we have a question here. It says it's a great example of streaming data, but most organizations don't have the people or the training, or I'm going to add the organizational understanding. If you can't handle the detail, how do you start small? And I'm just going to give my perspective here, and then, Jim, I'm going to ask you. I think the first thing you got to start with is educating yourself about open source, and then I think the next thing is every vendor that comes to see you and talks about real time, I think you got to press the issue and say, what do you mean by real time? Because I find that almost all vendors use the term real time, but they're really dealing with batch. And, so educating yourself. And then I think you can start small with companies like Savvy, and there are a couple of others that are working on Apache Spark for specific applications. There's one company I've been working with on digital manufacturing that works sort of like Savvy does on how to take signals out of manufacturing. Savvy is doing a lot more work in transportation. So I think you can let the vendors that are growing up in this space on the Apache and open source code do some of the heavy lifting with a focus on solving a business outcome. And I think that, this example of in-transit visibility and real-time prediction is a good way to start small. So, Jim, what's your perspective? How do you start small? Because this is such a different world for most supply chain leaders that have been buying SAP and Oracle and JDA and fill in the applications with all the acronyms that, are relational and anything but streaming data. How do they start small and really solve a business problem?
Yeah, sure. So there's a couple of points here. I would never recommend rolling anything out across the globe at one time, right? You need to be able to roll this out at the speed you can consume the information. So pick one of your more advanced, either manufacturing plants or one of your more advanced distribution centers, or pick one where you feel you have the biggest blind spots, the lack of visibility, and start there. And start on a few lanes or one geography. And then define success, compare it to the as-is situation, and if you get a measurable increase in value, then you can present the business case required to be able to roll this out broadly. And that's
so, Jim, we got a question.
Sure.
Yep. We have another question from Ann. She's saying are we saying that there's no way to improve on the massive EDI structure that's in place already? And, Jim, EDI has been the workhorse of the supply chain for 40 years, and it's done a great job, and it's batch, and there's certain data that needs to be batch and should stay in EDI, right? But I think we've got to recognize the limitations of EDI, and will streaming data architectures with blockchain allow us to move data securely across organizations? That's part of what we're testing. Your perspective on streaming data versus EDI, Jim?
Yeah, I think there is a place for EDI, like you said. I mean, it makes sense where latency is not a concern. So if you're contracting for something or you're booking something, you use the EDI exchange because a day latency really doesn't, you're planning ahead, and having that much latency doesn't really make a difference. But when it comes to what's going on with my shipment right now, having milestone data only lets you know the location and state of your goods the last time somebody looked at them. The last time somebody, a human being, could say, okay, I touched this now. Whereas a lot can happen in between those milestones. And if you really want to know what's happening in between those milestones, you need to start thinking about this type of streaming data capture and processing.
Yeah, and really the purpose of this webinar is to sensitize you to start the journey of thinking. And just like the Lennox International redefinition of service, or the work that Caterpillar's doing on streaming data on heavy equipment, or the work that SAS is doing on asset utilization on windmills, we've really got to drive a business outcome, and Savvy's doing a lot of work on transportation and telematics. And then you've got to ask yourself, how do you improve the operation with that business outcome to really drive the project? What I'm really trying to start is the thinking that most of the marketing that we have in the industry from vendors around real time is really batch. And most of our processes are batch. And we're opening up the world to have Internet of Things and machine-to-machine interface, and we need to redefine the architectures to be able to use the data. And that's really the goal of the webinar. And I know, Jim, you've got a couple more slides here.
Yeah, so this one's an example of capturing streaming data and then adding contextual data to be able to tell what the impact is based on this fact I just received. So in this case, we're getting all these events. Every one of these lines on the bottom of the screen here, if we look at the left picture, is an event happening that I know something about. So the shipment's it was loaded, it departed, and now here's where it is. And here we are, 28th of March, and it's 4:30 in the afternoon, and I called my machine learning model based on knowing where this is and prevailing conditions, like the time of day, the number of hours the driver's been driving so far, and my predictive model tells me it's going to be late. It's supposed to be there on the 28th at 2200. I'm predicting it's going to be the 29th, more around 1430. And if we look at the right-hand side, we look at the very bottom right, we see that it did arrive March 29th at 1500. So my estimate was off by half an hour, but that was almost a day early. And so I learned about a disruption a day earlier than I would have, because this predictive algorithm let me know with that much advance notice that this particular shipment was going to be late coming to my destination. That's an extra day you have to make a decision and react to this disruption. And
so I think you've got some other examples here, right?
So the purpose of this is just to show you the amount of data that can actually be generated from the streaming data. It's not just this piece of data that tells me, here's this shipment, here's where it is right now, and here's the condition it's in. If I add contextual data, I can understand, okay, based on when it was supposed to be there, how late is it going to be? And then I can do things like generate alerts. But this streaming data, when combined with all of this contextual data and then looked at over time, allows you to optimize your business. So the real-time aspect is to deal with operational issues associated with disruptions, whereas capturing this data over time and understanding it can help you optimize your supply chain, get slack out of your supply chain, pick the right carriers, pick the right shipping lanes based on all of the factors that could impact it.
Okay. Well, the goal of this webinar, and Jim, thank you very much, is really to just start this conversation about streaming data and open source code and alternatives. And, as people sit back and they think about this, a couple of things I want people to really think about is all data doesn't need to fly first class. It doesn't need to all be real time. So a lot of times I'll see a visibility strategy document and people will say, I need real time data. And I say, what are you going to do with it? And let's separate real time data and streaming data and the outcomes. So most of the time it's service or asset utilization or replenishment or VMI or telematic signals. And let's separate those needs for streaming data versus your batch processes, and let's look at how can they coexist to drive business outcomes. And then, it's not an evolution, so it's not something that you can just stuff into your existing architectures. It's really a revolution to really be able to think about different architectures, different sets of vendors, and different processes. Our current processes don't have a place for real-time data. But the new technologies, the open source code, the sensor technologies offer great promise because, today's supply chains can't sense. And I've got a question. Does real-time data modeling fit for the fast-moving consumer goods products? And I think absolutely. McDonald's could have real-time streaming data in McDonald's Coca-Cola machines to drive replenishment like Costa Coffee. We have smart shelves that are going to be developed for end-all displays because we're not always good about refilling shelves. We have smart hangers and a lot of apparel manufacturing specialty stores that tell us what's going to be sold. The average fast-moving consumer goods company gets 5 telematic signals from their carriers about where shipments are, but they don't have any place to put them, and so it's really ad hoc. And if you look at the deductions and the charges by Walmart on the on-time delivery, it would be great to have that data synchronized and have prescriptive alerts. In addition, as we look at the current state of the ocean freight industry and the level of uncertainty and risk of containers that are on the water, when we had the bankruptcy, there were a lot of containers that people didn't realize were on the bankrupt carrier because the companies will transfer containers without the shipper's knowledge. So those are all examples of streaming data. Additionally, we don't use social data, social sentiment data that could be used for new product launch and new product launch acceptance. So I think we've got a lot of opportunities for streaming data, but we need to think about, whether it's a tank sensor or an RFID on a rail car, or where's the container, or the telematics coming out of a truck, or the pump motor signal on redefining digital manufacturing. We've got to think about, how do I redefine processes? So Jim, thank you very much for your time today. We will be talking about streaming data and Internet of Things at the Imagine conference in September. It will be right outside of Atlanta this year. We have 5 themes: the supply chains to admire, changing economies and changing times, globalization versus nationalism, and we'll be talking about digital supply chain innovation, transformation, and talent. Registration's open, and we look forward to your thoughts. Helen, I'll turn it back to you.
Thanks, Laura, and thanks to everyone for joining us today. A few things to share before we wrap up. As I mentioned, we will send out the slides and recording link to everyone on this webinar, so keep an eye out for a follow-up email from us. We also encourage you to engage with us on social media by following us on Twitter, joining our LinkedIn company page, and following us on SlideShare. You can find this information in the slide deck. We also invite you to join our next webinar, How Open Source Will Drive the Future of Supply Chain, on February 22nd. Thanks again for joining us, and we hope to see you again soon.